apply this section. So there's not any other vocabulary or information I need to give you. I just want to look at some examples with you, okay? Katrina, can you put your book away from me? Thank you. All right, so we want to draw the border of the photo after a dilation with a scale factor of 5/2. Again, if they give you the scale factor and dilation and they don't tell you the center, you're going to assume that the center is where? The origin, okay, at 0, 0. So that means we're going to grow and increase this enlargement by a factor of 5/2 from the origin. If it's at the origin, it's super easy to get your new coordinates. You just take your old coordinates and do what? Multiply it by 5/2, your scale factor, okay? So it's not anything hard at all here. I just wanted to make sure that you understood what you were supposed to do. So if I have this point at 0, 0 and I multiply it by 5/2, does it go anywhere? No, it stays right there. What are the coordinates for point B? Okay, if I take 0, 4 and I multiply them by 5/2, what do I end up with for B prime? 0, 10. Is everybody with Miranda? Okay, so then what I would have to do is increase this way up, and I would go to 10 and plot my point and label it B prime. And what is this point labeled? A prime. It stays right where it is, but it's also labeled A prime. Okay, what are the coordinates for D? 3, 0, and now we're going to multiply those by 5/2, and what do we get? So Alexis is on the ball here, so we go on out, 5, 6, 7, 8, and if I multiply by 5/2, that's 15/2, which is 7.5. So 5, 6, 7.5, and label that B prime. And then I need C prime, right? So C is at what point? 3, 4, and so when we multiply it by 5/2, where is C prime going to be? Good. 7.5, 10. So we're going to go up here and put C prime, 7.5, 10. I should have labeled those all along. This is 7.5, 0. And this is going to be at, we said 0, 10, right? And then you would just connect the dots. Draw your shape, and you have the border. Now, if you are very artistic, by all means, feel free to draw a horse inside of that big giant rectangle. But you do not have to, okay? You sure can. Okay, but you don't have to. Is everybody clear? Okay, super simple if it's centered at the origin and they tell you what the scale factor is. I want to remind you though, how do we find the scale factor if we don't have it centered at the origin? Image. Very good. Image over pre-image. So if we didn't have it centered at the origin, we would have to take the length of one side and divide it by the length of another side that it corresponds with. And we would always do image divided by pre-image to get that. Okay? All right, so the next kind of examples that you see, they say given that the two triangles are similar, they're going to ask you now to find some missing coordinates and find the scale factor. Okay, so we're looking for what are the coordinates of point U. That's what they want us to find first. And then what is the scale factor? I'm going to tell you I think it's easier to work this problem if we do it backwards. If we find the scale factor, then we can find the coordinates of U. Okay, so when you're comparing these, you have your two triangles are similar. So we have this triangle here, similar to the great big triangle. What can we do to find our scale factor? Okay, so we could find the length here from R to O. What's R to O? Okay, it's a distance of negative 12 because we're going left, but the actual measurement on the side of the triangle would just be positive 12, right? The negative is just because we're going to the left. All right, and then we could find, Ridley said, the distance from T to O, which is, and again, it's to the left, so it's negative, but it's a distance of 9. Okay, and then what would we do to find our scale factor? Be very careful. This is how it's named, and what did we learn about how it's named? Does the 12 go on top or does the 9 go on top? It matters because it was given to us as a similarity statement. Okay, so whichever one is named first has to go on top, right? That was our rule. So since they said TUO is similar to RSO, then that means the 9 has to go on top and the 12 has to go on bottom. So my scale factor is 9 to 12 or 3/4. And always reduce your scale factor. So the first part there, what's the scale factor? It's 3 to 4 based on the similarity statement. Now, Javi said it doesn't matter, right? And it doesn't if you're writing the similarity statement and you're writing the similarity ratio. But if they are asking you to do it and they give you the statement, then you have to make sure whatever they did first goes on top. It would be 4/3, right? But that wouldn't match with this statement. So that's the kicker. If they're saying TUO is similar to RSO, that's in a ratio of 3 to 4, not 4 to 3. Okay? So that's why it matters. Okay, so now how would we use that to find the coordinates of point U? Okay, so we know that the distance from S to O, right? Not R to S. I guess we could. We could do distance formula. That's going to be a little more work. But we could do S to O, and that would be a little easier since it's vertical, right? Okay, so what is this distance? 16. And then we're trying to find this distance, right? Which is, we can just call it X, right? Okay, and then you can write a proportion. 3 to 4 should be the same as what to what? X to 16. And then you're just going to solve. So what would we do to solve? You can cross multiply or you can multiply both sides by 16. Doesn't matter. If you cross multiply, you're going to get 4x equals 48. And then divide by 4, and what do you get? 12. Or you can multiply both sides by 16 to get rid of the 16, and you still get 12. So that's x, but what is our answer since it wants the coordinates of U? Okay, 0, 12. And that's where you're going to have to take into account, are you going up or down? Are you going left or right? Because it may be that it's a negative 12 if it had went down. Okay? Does that make sense? All right, let's look at one more. So here's this one. You guys go ahead and try it. See if you can find the coordinates of n and the scale factor. Don't forget your ordered pair. Parentheses. Scale factor. Okay. Okay, let's check and see how you're doing. So first you had to go around your picture and label the points this time. and then Q was at 0, negative 30. So when you did your scale factor, you should have found that this distance was 10, this distance was 15, and then the first triangle that was named was MON, which was the smaller one. So that should be 10 to 15, which reduces to 2/3. Make sure you circle your scale factor is 2/3. From there, you could write a proportion. You're trying to find the coordinates of N, so you need to know the distance from O to N. And you know the distance from O to Q is how much? 30. So your proportion then would be 10 over 15, or you could have just used 2/3, equals X over 30. So then that gives us 15X equals 300. Divide by 15, and X is 20. But then be very careful. You're going down 20, so what are your actual coordinates for point N? 0, negative. Yeah, I would have probably. I just set it up, so yeah. Be much easier. Yeah. Then you could just have 3x equals 60, so x is 20, right? But it should be negative 20. Is everybody with me there? Questions? Okay, the last thing we're going to do is one more example on the back, and even that there's extra examples back there, but I'm not going to do them because we don't need the practice if you're getting this, okay? So there's just one more problem I want us to look at, and it's the proof.
Which other's 3?
Yeah, the other ones aren't. Well, we're going to do one of the proofs, and then we're not doing the quiz, okay?
Oh, that's...
Do you see? Okay.
Oh, part of the quiz.
Mm-hmm. So there's a quiz there just in case we needed more problems if you were having trouble, but if you're not having trouble, I'm not going to do more problems. So here's the one I want us to look at. I went ahead and saved time by giving you the picture of the graph already, but if this were on your homework, you would have to graph these, this shape, okay? So you would graph it and you would get the picture that you see on your paper, oops, right here. Everybody good so far? Okay? They want us to prove the two triangles are similar. What are my 3 shortcuts to prove they're similar? Angle, angle, similarity. SAS, similarity. And then side, 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 similarity. Okay, don't forget those little squiggly similarity marks, okay? There is a long way to do this problem, and there is an easier way to do this problem.
Isn't there like a...
Mm-hmm. So what I would tell you is, what is the easiest one to prove if possible? Angle, angle. So you're always should look for angle, angle. So if I look at this, what's the first thing I notice, Miranda? E. So if I'm writing this as a proof, I have my given.
Oh, no.
Mm-hmm. Statements and reasons. And number 1 is just, we're given all of those points. And I'm not going to rewrite all those points, okay? But I'm just going to put a little arrow here. Yeah. If it's on your homework, you'll have to write all the points. But for time purposes, I'm just going to draw an arrow. You would have to just list all those. Yeah. Okay. So then we plot all those points on our graph, and we have this picture that accompanies our proof from plotting those points. Second thing we noticed is Alexa said angle E is congruent to angle E. By reflexive property of congruence, right? And we can mark that angle in both the little triangle and the big triangle. That angle is congruent to itself. Okay, what else do you notice here that we could use? Okay, we do have parallel lines, but we have to prove they're parallel. So what would we use to prove those lines are parallel? Slope. So number 3, we would need to find the slope of our 2 lines that look parallel, which are HJ and FG. So I'm going to write down slope of HJ and slope of FG. And what is the slope of HJ and FG? You're trying to write an equation of them. What is just the slope? should be 0. Remember, horizontal lines have a 0 slope because you are rising 0 and you are running an infinite amount of space depending on how long your line is. So 0 divided by any number is just 0. So the slope would be 0 for both of them. Okay, what tells us, how did we calculate that slope? What do you use to find slope? Okay, rise over run, which is the slope formula, right? So this would just be from the slope formula. Okay, we can't go there yet because what do we need to say now that the two lines have the same slope? That they're parallel. So first we have to say they're parallel. So we would say HJ is parallel to FG. And what tells us that if they have the same slope, they're parallel? Definition of parallel lines. You can just put parallel. And now, because those lines are parallel, what do we have? Okay, we have corresponding angles. Which angles are corresponding? Okay, be more specific. There's more than one angle at F. Okay, EFG. And we can call it just H if you want because there's only one angle at H, right? But there are two angles at F, so we have to use 3 letters. So EFG and angle H would both be corresponding. Do we agree? Okay, so then number 5, I'm kind of running out of room down here where you can see, so I'm going to come up here. Angle EFG would be congruent to angle H, and that is by the corresponding angles postulate. And you'll notice how this stuff doesn't go away, right? It just keeps building. We're in chapter 7 still using that stuff from chapter 3. So it keeps coming back to us. And now, why are the two triangles similar? Angle, angle. And I should have used a different number of marks here. That's bad notation there. Sorry. So we can say the two triangles are similar by angle, angle. And definitely, yes, use that similarity symbol. So triangle EHJ is similar to triangle EFG. Now, I told you this could be a long proof or this could be a short proof, right? And we chose the easier way, which was angle, angle. Always look for that first. But let's talk about what would I have to do if it wasn't able to be proven by angle, angle. So you would have to find the sides, and the only difference is you would do your work to find that answer for distance, and then instead of using slope formula, you would say distance formula. And so you would find the side lengths, and then you could say that those side lengths are equal by transitive, and then if the side lengths are equal, they're congruent by definition of congruence. Does that make sense? But you would have a lot of work because you would have to do it for every pair of sides, at least twice, 4 times, because you'd have to do it for each pair of sides so you could get side, angle, side. Does that make sense? So you'd have to do distance formula for EF, distance formula for EH, distance formula for EG, and distance formula for EJ. And then show that they are congruent using transitive and definition of congruence. So I don't think you'll have anything that hard, but you might if you don't look for angle, angle first. Okay, so that's why I wanted to show you that you could prove the lines parallel to make that easier. Okay, any questions on 7-6? Okay, it's not really any new content, just approached a different way. And so I wanted to make sure that you could do those examples. That's the end of chapter 7.